Okay, so we're going to try and finish our notes, or really part 2 of our notes. So we should have just finished up talking about functions versus not functions. And before we go any further, I want to talk about something that I forgot to add on your notes. So we'll save that for a minute. So if you go to the back page of your notes, you'll see examples that look like this. We'll talk about this later. But at the bottom, you should have just like some blank space. And we're going to talk about 2 important things that I forgot to add to the notes. So we're going to talk about domain and we're going to talk about range. Anytime you're talking about graphing, you're talking about functions, you're talking about ordered pairs, mappings, anything, there are 2 phrases that are going to come in play. The first one we're going to talk about is domain. So domain is going to be your set of x values, meaning this. All possible x values that could happen in your function. Then we're going to talk about, next word, your range. And your range is your y values. If I gave you a bunch of ordered pairs, say 3, 2, 4, 5, 7, 6, and I said list your domain. If I wanted you to list your domain, we'd use squiggly brackets, and I would say 3, 4, 7. I like you to write them from small to big. If I said write your range would be all your y values. Squiggly brackets, 2, 5, 6. Close them off, and you're done. As we start graphing things more, so units 3 through the rest of the year, you're going to start seeing graphs. And I'm going to say, look at this graph. Tell me what you know about the x values. Tell me what you know about the y values. For the most part, your domain or your x values on most graphs will always be all real numbers. Meaning your x could be any value. I could plug an x into any graph and I could come up with a y value. For right now, our y values are also going to be all real numbers, but as we get into more complicated things, in second semester, we're actually going to have a lot of limitations on what our y values could be. Meaning, depending on what the equation that we have looks like and what our graphs look like, our y values are going to be limited to what could happen. But that's a long ways down the road, and I'm not worried about it. Big thing you need to know right now, your domain is your x's, your range is your y's. Go ahead and flip back to, I think it's the 3rd page of your notes, which should be the next part that's blank. And we're going to talk about continuous versus discrete functions. So I'm going to try and make this short and sweet. So usually when we talk about continuous versus discrete, we're talking about graphs. So my definitions are going to have graphs in them. So a continuous function is going to be any graph with a fluid line connecting data points. And really, you don't even need the data points. But what I mean by that is this. If I have a dot here, I have a dot here, I have a dot here, and I have a dot here, if I connect them with a line, it's fluid, meaning it doesn't stop and start. It's one fluid continuous line. This is called continuous. Usually continuous lines will also have the arrows on the end because that means that the line would keep going past what I can show on the graph. Another important thing that you need to realize when we're talking about continuous graphs is that it's not just the data points that I drew specifically, but actually in any data point, so here and here, anywhere on the line is technically a point on the graph that will work. So biggest thing you need to know about continuous is a continuous graph is going to be a line that connects the dots. So now I'm going to come over here and I'm going to go to discrete. So a discrete function is going to be the opposite of that. So I'm still going to have data points, but this time my data points, I'm not going to connect my dots. So if I had a dot here, and I had a dot here, and I had a dot here, and I had a dot here, I am not going to connect them. So graph with data points not connected. So it's a graph with data points that are not connected. So I am not going to draw a line to connect these dots. They're just 4 random data points that happen to fall on the same graph. Next quarter or next unit, we will talk about scatter plots, and scatter plots are a really good example of discrete functions, meaning that we're not going to connect our dots. So continuous, connect your dots, discrete, dots are not connected. Okay, so now we're going to scroll down and we're going to talk about linear functions. So really quickly, I just want to kind of show you where we've gone, where we're going. So we talked about relations, and I said, okay, relations is really, really broad. And then we got more specific and I started talking about functions. And I said a function is a relation, but it's a special kind of relation. And we talked about how every x has to have a specific y. Now we're going to get even more specific and we're going to talk about linear functions. So linear functions, hopefully when you see the word linear, your mind automatically goes to the word line. And a linear function is always going to form a straight line. So it's a function where on the graph, it's going to form a straight. I don't know how the guy on Khan Academy makes his words so pretty. Mine are ugly. It's going to be a graph that forms a straight line. So an example of what that might look like, I might have a line on my graph that's straight. Usually linear functions, that line is straight, make yours straighter than mine. Usually linear functions are going to have the arrows, which means it's going to keep going, which means it's continuous. Sometimes you might even have a graph where you have a line that goes across like this. Still a straight line, still linear. You have to remember, though, that we are talking about functions, so our function rules still have to apply. But both of these are examples of linear functions because they form straight lines. Something else that you're going to start seeing when we start talking about linear functions is I'm going to start showing you equations. So if I gave you the equation y equals 2x plus 3, and write that down, this, if I were to give you an x value and you plugged it in, replaced it, you would end up with a y value. So you would take your input, replace it, and then you could find your output. When you were to graph it, it would give you a straight line. So anytime you have something that looks similar to this, and we'll talk more about this in the very near future, a whole bunch, this is going to give you a straight line. You might even see something that looks like this, y equals 3, and y equals 3 could also work, and it's also going to give you a straight line. Hint, 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 if it looks like this, it's going to give you a horizontal line, but that's for later. So then we're going to come over to nonlinear functions. So nonlinear functions is going to be anytime you have a line that's a function, but it's not straight. So it's going to make, I lost my pen. It's going to make a curved or jagged line. Remember, we're still functions here. So an example of this could be something that looks like this. This is still a function because it passes the vertical line test. This is actually something called a parabola. So this is still a function. It's just not a linear function because it's not a straight line. Then you could also see something that looks like this. Again, still a function because it passes the vertical line test. Every x has its own y, but it's not a straight line. So since it's not a straight line, it's a nonlinear function. When we start writing equations for nonlinear functions, or if we want to compare, a nonlinear function would have an exponent in it for its equation. So my exponent tells me, oh, this graph is going to be nonlinear. You could even have something that looks like this, where you have the variable is an exponent. Both of these equations would make nonlinear functions. They're still going to be functions, they're just nonlinear functions. And in fact, we'll learn about this and we'll learn about this later on. So from this point, we're done with this video. You're done with these notes. You should have tasks that I've already assigned you that you need to do since the video is over. Make sure you're staying on task. Make sure you're asking questions. If something didn't make sense, please make sure you ask.